Okay, for you. Is that the only problem on page 40? For you.
We do need to do for you and 40.
Huh? 40? Did you say for you? 3U, yeah, 3U, sorry. 3U. Okay, so we have minus 12 less than or equal to minus. Guys, hurry up. Come on. Minus 3x minus 18 less than or equal to 18. X is a natural number including 0. Okay, so I should add 18 to everything. So if I add 18 to everything, I get 6 minus 3x and 36 here. Yeah, if I add 18 to everything. Yeah. And then I divide everything by minus 3. So I get minus 2. Sorry, wrong way around. X. And then greater than or equal to minus 1, 2. I'm dividing by minus 3. So in other words, x is to be bigger than minus 12 and x is to be smaller than minus 2. But x is to be a natural number including 0. Any number between minus 12 and minus 2 that's positive? No. So we say there's no answer for x. So this symbol here means empty set, null set, no elements, no members, no answers. So this one doesn't actually have any answers. No answers for this.
And when you draw the number line?
You draw the number line, the situation is here is minus 12, minus 2, 0, 1, 2. So we're told that x is natural number including 0. So x could be here, 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 etc. But you're told that x should be between minus, well, you find that x should be between minus 12 and minus 2. So there's nowhere that the blue and the red meet. None of your answers that you found are the allowed answers. None of these answers are allowed.
So we just keep empty?
Yeah. Yeah. Number line's empty. Yeah. Yeah. Come on. Hurry up. No. She sat down there now. Too late. She did the responsible thing and sat quietly at the back because she was late. Okay. Now. What else do we need to see? Yes, 5A. So I knew the answer. I just wanted to see if anybody would say it. 5A. 4E. Nah, 5A. Who asked? Ali? Ali? Which one? 4E? For real? Alright. 4E. You know you're late again. Yeah? 4E. 29x squared minus 14x minus 5 less than or equal to minus 3x squared minus 2x plus 4. So take everything to the left. 32x squared minus 12x minus 9 less than or equal to 0. I can divide everything by nothing. No. Okay, so what are the two answers here on your calculator? You have A equals 32, B equals minus 12, C equals minus 9. Or we could try to factorize it. 16 and 2 and
4x minus 3.
4x minus 3.
8x plus 3.
8x plus 3. Great. So it's 3 over 4 and minus 3 over 8 are the answers. So I just draw a very quick sketch here. There's minus 3 over 8. There's 3 over 4. There's my quadratic. And do I want positive or negative? Positive or negative? I want, no. That's less than 0. So that's negative. See? Less than 0. This means I want negative. And negative is down here. This is the negative part of the graph. Which means I should use this for my x. So x is to be between minus 3 over 8 and smaller than 3 over 4. Or another way of writing it is like this. Minus 3 over 8 to 3 over 4. Like that. Yep. What's wrong?
I thought we put or and then we use like 8x plus 3 is less than or equal to 0, or x is less than x is greater than or equal to.
There's two ways of doing it. Yep. So we can do it that way or using the graph. I showed you two ways last time.
So
Yes.
the one with the number line.
Why are you so late? Guys, why are you two so late? No, I won't let you into this class. Go. Too late now, come on.
Like the number line?
Yeah, there was two ways to do this one. So this is the easier of the two ways. But if you want, we can do it the other way, where you say yes. So if this is negative, then what does that mean about these two? One is positive and the other is negative, or the first one's negative or the other one's positive. Is that what you're talking about? Yeah. But this graph way is what you should do in the exam because it's quicker.
I'll just.
Yeah, write this one down. This is the way, this is the preferred way to do it. Okay. And then in a moment now, we'll do 5a. Which I don't know if the answer's wrong, but I don't know if anybody managed to get the answer. Did anyone get 5a?
No.
Yeah?
Yeah.
Yeah. Yeah. Good, okay. Very difficult, but it's the most difficult one. In fact, I think it is maybe too difficult for the exam, number 5. Okay, so let's have a start of it here. 5a, we have 71 less than or equal to 2x squared plus 20x plus 49 less than or equal to 97. So I need to split this into two separate problems. And do I put and or between these two separate problems? Is it and or? It's and, yeah. So I have here 71 less than or equal to 2x squared plus 20x plus 49. And then here 2x squared plus 20x plus 49 less than or equal to 97. Okay, so this is 0 greater than, 2x squared plus 20x. Now what's 49 minus 71? Minus 22? Minus 22. And then here it's 2x squared plus 20x. And then 49 minus 97? Minus 48. Less than or equal to 0. I can divide everything here by 2. X squared plus 10x minus 11. And then likewise here, x squared plus 10x minus 24. So I have x squared plus 10x minus 11. That's to be positive because it's to be bigger than 0. And then I have x squared plus 10x minus 24, and that's to be negative. Two answers, probably 11 and 1, isn't it? X plus 11, x minus 1. So I get minus 11 and 1 here. And then this one, 12 and 2. Yeah. 12 and 2, isn't it? Isn't it? X plus 12, x minus 2. So I get here minus 12 and 2. And this one is to be positive. And then this one here is to be negative. So we can draw our graphs. So just roughly, minus 11, 1, and the graph is there. And then here, minus 12 and 2, and again there's a graph. So for the graph on the left, we want positive. Whoops. So we want this piece, and we want this piece. So that means I should use this value for x and this value for x. And on the graph on the right, I want negative. So that means I want here. So I should use this piece.
Why did you choose negative?
No, I didn't choose it because it's less than 0 here. Yeah. I didn't choose it. It chose me. All right. So, yeah. Math's life. Okay. So now we have to combine these two answers together. So on the left, it's x is to be, wrong way around. X is to be smaller than or equal to minus 11, or x is to be bigger than or equal to 1, and x is to be between minus 12 and 2. So if I try to put that on a number line, not to scale, minus 12, minus 11, 0, 1, 2. So here, I'll do this one here in grey. So that's less than or equal to minus 11, so that's here. And greater than or equal to 1, that's here. And then I'll do the other one here in red. Between minus 12 and 2. Now you need to look at this graph, this number line, and because of the and, you need to look where on the number line is both true. So both will be true. Both will be true between 12 and the minus 11, and then between 1 all the way to 2. But the question also says, if you see there, x is a natural number, including 0. So from the question, we're only allowed to use, in blue now, we're only allowed to use 0, 1, and 2. So now we need somewhere where these are both true and it is 1 or 2. So it's 0, 1, or 2. Well, there's only one place where all those three things happen at the same time, and that's here. You've got your 1 and 2, you've got your first solution in grey, and your second solution in red. So it's only 1 and 2 that's the answer. So it's 1 and 2, and that's it. X is 1 or 2. Yes?
How to do that in graphical method?
How to do what in graphical method?
Yeah, the number line.
Which number line? The last number line. What are you talking about? Here x is less than minus 11, so it's to the left of minus 11, and it's greater than 1, so it's greater than 1, and it's less between minus 12 and 2. So there's minus 12, and there's 2, and it's between those. It's just a norm. There's nothing fancy here. This is just a number line. Nothing fancy. Yes.
So could you
No. What?
Summarize.
Summarize what?
Like, because when I was writing it down,
You can watch the video again later. Yeah. Have you watched any of these videos?
Yeah, I watched the one about shirts, and it was too long and boring.
Okay. I don't know what to say. Just watch this. The reason I record the video so you can review it again.
Yeah, it was very educational.
Yes, very educational. It's Tanish. It's just a number line. So, like for example, if I said x greater than 1, there's 1, and then you just shade in everything greater than 1. Greater than or equal to 1 here. If it was greater than 1, just put an open circle to show that you're not counting 1. That's all I'm doing. Okay, I need to move on now. 44. Okay, binomial theorem now. Okay, first some definitions. So for example, if I write 3 with this symbol here, you read this as 3 factorial, and what it equals, 3 factorial equals 3 multiplied 2 multiplied 1, so that's 6. 2 factorial, that's 2 multiplied 1, that's 2. 1 factorial, that's 1. And 0 factorial, that's
0.
Gets them every time. That's 1. Okay, yeah. Now don't worry too much about that. You can just take it as part of the definition, and there'll be... No. Business students will see why in semester 2. You won't. So 0 factorial is 1. You can take that as a definition. Okay. A bit like when you put something to the power of 0, you get 1. Okay. Right, so that's factorial. So now I'm going to make some new function, binomial function or C function. So this function now, NCR. Chinese students, in China you would write it backwards, okay? In the West, we always put the bigger number on top. So NCR equals n factorial divided by r factorial multiplied by n minus r factorial. So for example, 5c2 would be 5 factorial over 2 factorial, and then 5 minus 2, 3 factorial. So that is 5 by 4 by 3 by 2 by 1 all over 2 by 1 by 3 times 2 times 1. So what's that going to be? 10, is it? Yes, it'll be 10. Your calculator has this button on it already, though. I think it's usually on the divide symbol, is it? Yeah. Do you see it on your calculator? Graphing calculator.
Somewhere.
Yeah. Yes, this is why we don't use graphing calculator.
Speak to me.
Yeah. I would like people to type this in on their calculator. 4C0, 4C1, 4C2, 4C3, 4C4. So this is 1. What's this on your calculator? 4. Next. 6, 4, and 1. What's wrong? Do you know where it is on the calculator? It's usually on the divide button. Not always. Yeah. Do those numbers look familiar? Yeah. From Pascal's Triangle. Yes. So, you can make Pascal's Triangle this way. 0C0, 1C0, 1C1, 2C0, 2C1, 2C2, 3C0, 3C1, 3C2, 3C3, and then the one I just did, 4C0, 4C1, 4C2, 4C3, 4C4. So if you want, for example, row, let's say 10, or no, sorry, I'll rewrite that. If you want to do power 10, then you'd have to calculate on your calculator 10C0, 10C1, 10C2, etc. So this is a lot quicker than drawing the triangle. That's the point. You don't need to draw the triangle now. So in the last class, come on, what's wrong? Look, have you got a Casio calculator like I asked you to buy at the start of the course? Do you have a Casio calculator? Do you have a Casio 991 calculator? Take it out. It has it on it. Take out the Casio calculator. You're delaying me. Just take it out of your bag. Yes. Look how ridiculous that is. You have to press 6 buttons to shut it down. Take out your calculator. All right. We're going to do this the hard way. That's fine. Now, in the last class I told you Pascal's triangle is what you need to expand. You can also use this binomial theorem, binomial function here. So I'll show you, you don't need to necessarily write that down. I'll show you an example. So I'll do, yeah. You want it as a formula laid out, yes? I'll do that. This is binomial expansion, yeah. The theorem basically says, if you have x plus y power n and you want to expand it, that's nc0 xn plus nc1 xn minus 1 y plus nc2 xn minus 2 y squared, etc., etc., all the way down to the end, which would be ncn yn, like this. So really all I'm saying is you can use the c's instead of Pascal's triangle, which I'll show you now in an example. So for example, minus 2x plus y squared. Just a small example to get the idea. Okay, so here I would start off with 2c0 minus 2x squared plus 2c1 minus 2xy plus 2c2 y squared. Take out the calculator. This will be 1. This is 4x squared. That's 2. So that would be minus 4x times y plus, and then that's a 1 again, y squared. So the answer is 4x squared minus 4xy plus y squared. Let's do an example with a bigger power. So let's say b then. No, let's say c. 3x plus y power 4. Okay. So we start off with 4c0, 3x power 4, plus 4c1, 3x power 3, y, plus 4c2, 3x squared, y squared, and then finishing with, 4, make more space, c3, 3x, and then y cubed, and then finishing up at the end here with 4c4. Finishing up with 4c4, y4 at the end. I can pause for a second. Do you need to speak to me or them? Oh, yeah. Yes.
So what's the difference between using the Pascal triangle?
Yeah, what's the difference? There's no difference actually. It's just this way is quicker when you have large powers. But it's just a different method. Okay, so if we take out the calculator, 4c0 is 1, and then 3 power 4 is 81. So I get 81x4. And then 3 cubed is 27 times 4c1. 27 times 4 is 104. It is? Is it? Yes? Wait, what? 104? 108, sorry. Okay, 108 x cubed y. Now, 3 squared is 9, and 4c2 is 6. 6 times 9, 54. X squared, y squared. Plus 4c3, which is 4, isn't it? And then times 3, so that's 12. X, y cubed, plus y4 at the end. Yep. I want to do some more examples now because that's only question 1. Okay. Just before I go on to the next example, I just want to point something out that some people may have noticed. But if you look here, this 0 here, this 1 here, or this 2 here, or this 3 here, it must always match with one of the powers. So for example, there's a 3 here, there's a 3 here. Well, there's 2 2's there, so there's a 2 there. There's a 1 here. Where's the power 1? On the y. Also notice the powers actually add up to the upper number. So that totals 4. Like here, 2 plus 2, that also totals 4. 4 plus nothing, that totals 4. So what I'm trying to point out to you is the OR must match with one of the powers, and the AND always equals the total in the powers. That will be useful to know in the next one, which I'm going to do. So this here is 2. X minus 1 squared. So it's, what is the coefficient of x in x minus 1 squared? You know what, actually I'll make it a bigger power to make it a bit more difficult. We'll just change the power.
Why can't we take 18?
Alright, let's take 18.
What?
Well,
Can you use your calculator? That's the answer. 45.
hold on here, don't confuse me.
What do you have to write a lot?
No, you don't actually. This is the thing. Power 18. So the idea is this. We imagine we expand it. So we have many, many terms plus the term we want plus many more terms. And I only care about the term that has x power 1 in it. I don't care about the x squared, I don't care about x cubed, I just care about x. So when I look at this, this has 2 parts, x minus 1. Sorry, x and minus 1. So here we have x, and then we have minus 1. And then I have my c in the front. I'm going to remove this box, it's in my way. C. Now, I only want x power 1, right? I don't want the other pieces. So let's pretend I'm looking at that piece with x power 1 in it. But I automatically know what this number here is. It's 18. Why is this number 18? Because the power is 18. And I automatically know what this number here is. 1, because it needs to match that one. And I can find out what this number here must be. What is it? 17. So when I type this in on my calculator, I get 18x and a minus 1. So I'll get minus 18x plus what's 7? 18c1 is 17? C17? Oh yeah, it's the same as 18c1. Is 18c1 18? Yeah? Yes? Yeah? Okay. So the coefficient, my answer, oh by the way, if I didn't say it, I think I might have, coefficient means the number in front of the x. So the coefficient is 18. That's the answer. Sorry, minus 18. That's the coefficient. Yeah. Okay, next one now. I've seen this in the exam, and the next one I've seen in the exam as well. Okay. Scrolling down. This is 3a. 2x minus 1 power 4. Right, let's check some vocabulary. So, ascending, what does that mean? Yep. Increasing, small to large. Descending, large to small, decreasing. So here they want ascending. But notice that they say in the question up to the third power only. Up to the third term only. So they don't want the full expansion here. They just want the first 3 parts of it. Okay? So what that means is I just want 4C0. Now, yes. 2x minus 1. Sorry, what am I doing? 2x power 4 plus 4c1, 2x cubed minus 1 plus 4c2, 2x squared minus 1, etc. Squared. So that would be 2, 4, 8, 16, x4, 2 cubed is 8 times 4, 24, x cubed. This is wrong, right? Well, not that it's wrong, but it's not the right answer. I have to show you 2 things for this. Plus 4c2, what's that? 4c2, is that 6? It's 6? 6 times 4, 24x squared. Plus. Now that's actually wrong, because what's happening to my powers? Are they increasing or decreasing? Decreasing. So they're descending. And what did the question ask for? Ascending. Now that's fine. I wanted to show you both anyways. This is what you would do if they ask you for descending. So does anybody know how do I fix it to make it ascending?
Change the power to x.
Yeah. We have to change the powers, but what way am I changing the powers? Yeah, swapping them. Or in other words, I can start from the back. You're allowed to start from the front or the back. So if you wanted the other way around, you should start at the minus 1. So you get 4c0 minus 1 power 4 plus 4c1 minus 1 cubed 2x plus 4c2 minus 1 squared 2x squared. So that would be 1 plus, no, minus 8. What's wrong?
Why are you using different number? You already solved it.
Huh? Swap them? Yeah.
Minus 1.
Yeah. Minus 1. But it's like I'm doing this instead. Minus 1 plus 2x power 4. I just swapped them around.
Yeah, but why are you using it? What's the reason?
Why am I using number 4?
No, minus 1. Like, you already solved it at the top. Yeah.
Swapped it at the top? I don't follow.
2x. You use 2x and then you solve it.
Oh, this isn't the answer though. This is if the question asked for descending. So this is what I'm supposed to do if it's ascending.
To use the second.
To start, yeah, use the second one first, yeah. Okay, here, 2 squared is 4 times 6, 24, yeah. Okay. So that is now ascending powers of x. That's actually the answer.
So it's a rule. You always use the second digit to find.
No, not necessarily a rule. If you notice, look.
Do you know that you have a mistake in descending?
Which one? Descending? Oh. It's not 24? What's this?
Minus 32.
Thank you. Okay. So, answer your question, Hussein. Whichever one you choose to start with, it will ascend with that one. So, for example, here I chose 2x. So sorry, descend with that one. So here I chose 2x. Descend, ascend. I need to swap them. Descend, ascend. I want the 2x to ascend. The one at the back is the one that ascends, and the one in the front is the one that descends. No?
But how would the placement of the number change?
Yeah, well, let's have a look at some examples. So let's say I say 2x minus 3. If I want to ascend powers of x, if I choose this one here, that would be descend. So if I want to ascend, I don't choose this one, I choose the other one. Okay? This one here is descend, this one here is ascend.
Because it's negative?
No, just because it's in the second place. So if I want ascend, if I choose to start with 2x, keeping it as it is, it will descend, like I saw in the first example. If I wanted to ascend, I should start with the back. So if I wanted to descend in x, I choose the first one, and if I wanted to ascend, I choose the back one in x. But that's because the x is in the front. If it was the other way around, then that's, you flip it. Okay, so here, if I want to ascend in x, I start with minus 3. And if I want to descend in x, I start at 2x. If I want to ascend in x, I start at 3. Minus 2x? Sorry, I can see it right there. Yes, start at minus 2x. And then if I want to descend in x, I start at 3. So just write dA above the 2, and if you want, whichever one you want. So if I want to ascend in x, I start at the back. No, there's that backwards, isn't it? I was right the first time.
You can just change T and A.
It's the wrong way around. This one, 3, isn't it?
Yeah.
Minus 2x. Anyways, hey, you're looking worried. That's fine. I never remember this anyways. I always just start with 1, and then when I start to see that it's not going the right way, then I swap it.
So
What?
trial and error?
Well, there's only going to be a maximum of 2, you know. Because if it's not one way, then it has to be the other way.
And how do I see the
Oh yeah, well look here. Yeah, how do you see? What's the starting power with x here? 4, isn't it? So what's the only way that the power can move now if it's already at 4?
negative?
Yeah, so here the powers are descending. So the moment I wrote x power 4, I should have stopped and then looked at it the other way. Now, what's the power of x here? 0. There's no x. So then what's happening to the x power here? Ascends, yeah. Yes?
So to know there's ascending, it depends on the x.
If it's ascending or descending, it depends on the location of the x. Yeah, that does matter. And it depends which one you take first as well when you expand. Alright, let's look at a more difficult example. Okay, I'm going to do 3i. Okay, so we want this descending. Now, if I start with the 2, then I have no x, and it's increasing. So that's bad. So I should start with the 2x, then it's decreasing. So I have 3c0 minus 2x cubed plus 3c1 minus 2x. I need space. 2. And then I have 2 plus, now I'm not deleting it, I'm just writing it again but with more space, okay, because it's a bit cramped. Okay. 3c0 minus 2x cubed plus 3c1 minus 2x squared times 2 plus 3c2 minus 2x and then 2q dot dot dot. And then the other one, multiply this one. So if I put the x first, it decreases. Yeah. So I get 5c0 x5 plus 5c1 x4 plus 5c2 x cubed. I didn't bother to write the 1 in because 1 power 5, 1 power 4, it's the same. Yeah?
Shouldn't it be 2 squared? Yeah.
Sorry, did I 3, 2, 1, 0? Oh, here it should be a 2. Thank you. 2. Okay, calculators now. So the first one, minus 8x cubed. And then this one here would be 4 times 2 is 8 times 3. 24, is it? 24x squared. And then this one is 2 squared 4. 4 times minus 2 is minus 8. Minus 8 times 3 minus 24. Is that right? X dot dot dot. And then this one here would be x5 plus 5x4. What's 5c2? Is that 6? Or is it 10? It's 10, right. 10x cubed dot dot dot. Now this isn't finished because we need to multiply these together. Okay, but we need to do this smartly, because if I didn't do it smartly, I would have 9, isn't it 9? Yeah, I'd have 9 multiplications to do. I don't need to do as many as 9. For example, if I multiply the first one with the first one, what's the power of x that I get? X power 7. 8, sorry. X power 8. But I only want 3 terms. So my first term would be x power 8. What would be my next term? X power 7. And then my next one would be x power 6. I don't need to do any of the multiplications that make smaller than this. So if there was an x5 or an x4, I don't need to look at it. The next one I need to look at is x power 7. So what would make x 7? Well, this one multiply this one. That would make a 7, wouldn't it? Yeah. And then if this one multiplies this one, that would make a 6. No good. What about this second one with the first one? Would that make a 7? Yeah, it would, wouldn't it? So the second one with the first one. So now I have 2. First with second. That's minus 40x7. And then I said the second one with the first one. Plus 24x7. Okay, and what's my last one I need? 6. So, what about the first one with, which one? The first one with the third one, yeah? So that would be minus 80x cubed.
Then the second one is
The second one with,
second.
oh sorry, yes, 6, thank you. Second one with the second one?
Yeah.
Second with second, so that's 96 is it? No, sorry, it's not. 120? 120? Yeah? 120 x 6. Anything else?
The last one and the first.
The last one and the first one. Minus 24x6. Okay, so if I clean that up, I get minus 8x8. What's that? Minus 16. x7. And then that's 120 minus 80 is 40. Minus 16 again? Plus the other pieces. Okay, write that down, please. Oh dear.
I got confused with the way.
Yes, it is confusing. Plus 16, thank you. Plus 16. But why is it plus? Yeah, plus 16. Okay, did you write that down?
Yes.
Yeah. Okay, now before you go, I just need to take the attendance and let me tell you which ones to do. So, GH, HP, so GH, HP, and you can try for A as well. Yeah. So GH, HP, and then A. Now wait, don't pack up because I just need to get the attendance since a couple of people weren't here. So I'll start with group 2. Yusuf,
Yep.
Hussein, Sherry, yes, Sanetta, Elsie, Grace, Anthony, Naveed, yes, Charles, the original, yes, no, I didn't let him in, it's a difference. Mohammed Abdel Wahab, yep, Tanish, yes, Tal, Joshua, yes, Sultan, yes, Angela, yep, Olivia, Don, Ali, Rasmisa, Arif? No? Luke, yes. Daniel? Yeah. Ire? Soon? Yes. Donna? Yes. Mohammed Al-Kahabra? That's Mo, isn't it? Again, 9 o'clock. Just too difficult. And Mohammed S? No. Right, now, before you go, later today we have our tutorial. And remember, this is the last tutorial before the exam, the mid-semester exam. Because the mid-semester exam will be Monday, 9 o'clock. So this is your time to ask questions for the exam. Or time to do more of the exam. It's on Moodle. Has anybody tried the exam on Moodle? Yeah, and do you have questions?
Yeah, I'm interested.
For real? Cool. All right, so later today,
I did the first one. He's hit the first one for every
no, I'm just happy.
I'm the pioneer.
No questions are good. It means you didn't find it too difficult, yeah? So 100% in the real exam?
The only problem they had was like,
Oh, there's always a problem, yeah. Yeah.
let's say 5 times 5 is 75.
Yeah.
Right, 5 times 5 answer 75. So it's considered as a problem that it's correct.
Yeah, I mean, I wrote
It's
x
not-
minus
it's not
1.
mistakes, that's-
Oh, no, I'm not talking about the quiz.
There's another quiz.
Yeah, there's another quiz. I'm just talking about the exam, the practice exam. Have you seen that? Does everybody know what I'm talking about? That means yes.
It's the one at the bottom.
It's the one at the bottom of chapter 2. It says practice mid-semester exam.
Be more like this, guys.
Yeah, all right. I'll see you later.